So your flammability, combustibility limits, if you have fuel and oxygen, but it's too lean, there's not enough of it, then it's going to be called the lean region. The lean region, remember that. Not enough fuel, not enough oxygen to support combustion, it's in the lean region. But when you get enough of each and it's supported, all you need is that ignition source and you can actually have your flame. But you can also get environments that are too rich. There's too much either fuel or oxygen, and it's too much, it's too saturated. Within your toxics, maybe present before you enter, materials you use and things you do, so welding, soldering, brazing, solvents and cleaners, paint coatings and adhesives. If I could ask real quick, when you guys do get into confined spaces, do you ever actually have to weld or do any hot work in confined spaces? Have you had to before? Anybody? Yeah? Okay. When you do that, do you guys wear respiratory protection? Yeah? Okay. Your permissible exposure limit is what's the acronym is a PEL, and then you have your threshold limit value. So these are things that NIOSH and OSHA have come together and approved of, saying, hey, you can be within this environment for so many hours or so many minutes, depending upon the saturation. Your time-weighted average, again, is a concentration for a conventional 8-hour workday and a 40-hour work week, to which it's believed that nearly all workers may be repeatedly exposed day after day without adverse effect. I'm going to tell you something. If you get in a space and you start feeling funky, you start feeling weird, that'd be a good chance for you to say something and come out. I could tell you, has anybody ever went under 100% oxygen, SCBA?
I've been under fresh air.
You've been under fresh air?
I haven't been hooked to a tank, but outside of...
Like you had a hose?
Yeah.
Man, it kind of gives you, it almost gives you a headache.
I like it.
You like, oh,
It felt good.
yeah, it's like, man, super fresh, right? But the point is like, man, after a while, especially like, it just feels like your head's just being squished and it's uncomfortable. And obviously, if you're that new guy out on the site, like, all right, grab that single-bladed razor, get some water, go shave all of your face and put on your mask. And I'm just like, oh, man, I hated those days, right? And then you smell like rotten eggs for like 2 weeks because you came into contact with stuff. Even if you put Tyvek and everything else on. So, yeah, it's not always pleasant, but it could save your life. So, electrical, mechanical, biological hazards. So live electrical systems, we may have some of that inside of our confined spaces. You have mechanical, augers, motors, belts, rotating shafts. Do we have anything like that in our confined spaces? Yes. Okay. Should we turn those off and make sure people are protected from those? You don't want to get tied up in one of those, right? Biological, wildlife, biohazard, which is sewers, water. See, a lot of the times, even as a kid, right, you get, I know I did, when I was a kid, I got, curious. I'm like, man, what's that hole in the ground for? Pop that lid off real quick, and it's a sewer. I actually, not a funny story, but funny now looking back on it, I popped open this sewer lid in the street, and I knew we were doing wrong. We grabbed we grabbed a little tool and popped it open, and I was like trying to look up in there. You can have hydrogen sulfide in there, guys, and that could kill me and all the little kids that we were trying to do it. And of course, we were trying to lift it off, and I dropped it, and it landed on my finger and crushed my finger. And so I'm yelling, and then the neighbor across the street comes over to the flathead and pops that lid, and I run inside and hide because I was like, I'm in trouble, right? But thankfully, I did not go into that space because as a kid, it's like, I'm going to go down there. That could have killed me, right? So we don't necessarily know all the time. Ensuring safety when entry is necessary. We do have something called entry supervisors. You guys familiar? Your entry supervisors should be somebody who's looking at that space, making sure that the space has been tested atmospherically, you've identified the hazards, you are controlling the hazards, you're making sure as the entry supervisor that before you ever enter that space, your employees are going to be safe, right? That's your job as a supervisor, and I hope that that's being taken seriously. Now, within the safety realm, there's three ways that we could take control of hazards. There's engineering controls, administrative controls, and PPE. PPE is always your last line of defense. It is not your first. So people are like, I'll just wear a respirator. That doesn't fix everything, right? Does a respirator fix rotating machinery? No, it don't, right? There's plenty of things that we could do to eliminate it. So with engineering controls, the first and best strategy to control a hazard is at its source. Engineering controls do this. Unlike other controls that generally focus on the employee exposed to the hazard, the basic concept of engineering controls is that to the extent feasible, the work environment and the job itself should be designed to eliminate hazards. So the best time, if you're building a new area, the best time to eliminate a hazard is in the design phase. Oh, you know what? Let's set this space up to where people don't have to enter. We could put a glass on the outside that can handle the pressure. We're going to put something up to where an employee does not have to enter into a confined space. We've eliminated that hazard. Awesome. Beautiful. That's a good thing, right? If feasible, design the facility, equipment, or process to remove the hazard or substitute something that's not hazardous. If removal is not feasible, enclose the hazard to prevent exposure in normal operations. And where complete enclosure is not feasible, establish barriers or local ventilation to reduce exposure. A good engineering control would be lockout, tagout. You've eliminated the electricity, you've eliminated whatever that energy source is, you've eliminated it from accessing the people inside the space. That's engineering control, right? Instead of saying, oh, just let the guys wear PPE, or let's just put up this little barricade. It's like, no, dude, eliminate it. That's the best line of defense. Administrative control, simply, guys, is measures aimed at reducing employee exposure to hazards. So say, for example, you got somebody working in a space that does have an oxygen-efficient atmosphere, and let's just say, you know what, we're going to allow this person to work for 4 hours, we're going to allow this person to work for 4 hours, so that they're not just being overtaken all day long while working under air, because it is uncomfortable. But we'll do that to reduce some of that exposure. Or if it's an atmospheric hazard like hydrogen sulfide or so on. Personal protective equipment. If you can't eliminate the hazard, if you can't perform administrative controls to help mitigate the hazard, then you go into the PPE. And PPE, that's when you're like, okay, I can't ventilate it out, I can't close it or shut it off, so we're going to add air, but we got to go under air. We got that self-contained breathing apparatus. We have a rescue retrieval. We have fall arrest equipment because they got to work at heights when they get in there. Protective clothing, gloves, safety glasses, hard hat, respiratory. This is like the last line. We've done everything as due diligence is concerned, and now we just can't. This is our process going forward. Air purifying, again, we're not certifying you in respiratory protection. Has anybody ever been certified in a respirator before? Yeah. So there's something called pulmonary function tests. You'll actually go to a medical provider. They'll sit down with you. They'll do actually they'll fit your face to your mask. You'll do negative tests and positive tests on the mask itself for half face, full face, and make sure that you can, you have a good seal, and to make sure that you can actually wear it and not freak out. Some people can't handle putting on a mask. It makes them feel claustrophobic. Well, it's like, well, you're wearing this because you got to go in that tiny little space over there, right? So we got to be aware of that stuff. And here's the thing too, guys. I know we're guys and we could give each other a hard time a lot of the time. If somebody mentions to you, hey man, I'm not really good with tight spaces. I'm not really good with whatever. I wouldn't put that person in those spaces. I hope you don't either. I'm just being honest with you. I hope you wouldn't say like, dude, suck it up, be a man, get in there, handle it. And then you put them in a bad environment, and then they're smoked. You got something?
Come condenser clean out time. Hey.
So guys, it's like, hey, if somebody can't, yeah, it's like, hey, if somebody can't, don't throw them to the lions. Atmospheric testing, so multi-gas monitor, so you're going to be testing for oxygen, LEL, which is lower explosive limit. Remember that, lower explosive limit. Hydrogen sulfide, which is H2S, and carbon monoxide, your CO. You're going to test at various depths, 3 to 5 minutes at each, 4 feet in depth.